All right, so this is number 17 in the lecture notes, okay? The car is going through this little dip thing right there, and since it's curved, you can apply all the circular motion stuff you did, that it's just really going on part of this curve, okay? So if it's going in uniform circular motion, what do you know about the forces acting on the car? The net force must be equal to mv squared over r. That is the mass times the square of the tangential speed, that is the speed it's going, and the radius of curvature. Okay, so now in this situation, what is it that's providing that net centripetal force? I think that the best idea is, whenever you're considering forces, let's do a force diagram. We got the weight down, the force of gravity, which is equal to mg, and there's a force up on the person's bottom, and that's the normal force. So now notice that I drew the normal force as being a larger magnitude than the force of gravity. How did I know that? Well, Mr. Gorin, you knew that because if the net force has got to be inward towards the center of the circle, that means that the normal force must be greater than the force of gravity, since the net force is upward, the direction of the normal force. Okay, so now what can we say? Let's try and avoid math until we need to. Don't fall into the trap. The normal force is not always equivalent to the magnitude of the force of gravity. But I think that we can say that the normal force minus the force of gravity is equal to mv squared over r, right? And what is our unknown here? And let's keep that in mind, that we know that the normal force must be greater than the force of gravity. Okay, so we're solving for the normal force, so let's isolate that variable first, and we can get it on the other side just like so. Okay, so now let's check out, what do we have? Do we have the mass? Is that an actual number? Yep. What about the speed? Number? Yep. What about g? Number? Yeah. And remember not to use negative 9.8, but just 9.8 meters per second squared, because we've already accounted for the direction of it here. Okay? And now, what's left? The radius? Yeah. Got it. Okay, so I think if you solve this, it ends up being that the normal force is equivalent to 1141 newtons upwards or inward. All right, I hope that helps. Give me a shout if you have a question. You also may want to note, what does that mean? What does it feel like when you're going at the bottom of that sort of dip? Well, if the normal force is greater than the force of gravity, then you perceive your weight to be heavier, because what you perceive is that normal force, that surface smushing up against you. Glorious.